if you're asked to graph a quadratic function, you should be quite comfortable doing this, but I'm just going to go through the procedure that you probably want to follow in order to make sure you're sketching or drawing it properly. Now, the thing with a sketch is that it's not a perfect diagram, so you don't need to find coordinates and plot them. We're just looking for key features of the graph. So, we're going to sketch the curve y equals x squared minus 2x minus 3. So first of all, you look at this and go, haha, it's a parabola. Okay? So we know it's going to be either positively happy or negatively sad. We know it's a parabola. We need to find where the curve cuts the y-axis. How do we do that? What do we know when something cuts the y-axis? What value? It would be C, but what more specifically, like, so for example, if it was in this format, it's not necessarily, you can't necessarily see what the y-intercept would be. So what do we know? What value do we know when something cuts the y-axis? Yeah. So you sub that in, and that will get you your y-intercept. Similarly, how do we know when something cuts the x-axis? Y is 0, yeah. So you sub that in and find those values. We're going to do this in a second. I'm just going to briefly go through these. The roots of the curve, that's this. I don't know why I've written it separately. I need to change that. Basically, the roots are where it crosses the y-axis. X-axis is how it's basic shape of the curve. Is it positively happy, negatively sad? Okay. Sorry, I said happy or sad. And the coordinates of any maximum or minimum turning points. Okay. So this one may be a little bit more in depth. We know that parabolas are symmetrical. Yes. So we know that if we've got our two x-axis intersects, that our maximum or minimum point is going to be midway between them. Yes? Do we talk about that already? Not really? Okay, so we'll do it for this actual one. So it's symmetrical. So max or min is midway between x intersects. And then the y value of that is going to obviously be when you chuck this value into the equation, that will tell you the y coordinate on it. Right, so let's get going on this. Alright, so where does the curve cut the y-axis? So, feature A. We're going to say that y is equal to 0 squared, what's the equation? Are you going to write it in today, so you're not? Minus 2 lots of 0 minus 3. Which is negative 3. B, we're going to say that 0 equals x squared minus 2x minus 3. How would you solve that? What's your gut instinct telling you? Say it. You want to use quadratic formula? You could do. Or you could do. What's the speediest way of solving quadratic set? Try and factorize. That's your fastest way. Like, yes, you can totally use a quadratic formula. Yes, you can use a calculator if it's on paper 2. If it's on paper 1, this kind of question is more likely to be paper 1 because you shouldn't need a calculator to do it. The only drawback of using the quadratic formula is that it's a lengthy process. You make one small mistake, everything goes pear-shaped. So that's why we say if you can factorize, factorize. Okay? And you're looking for two numbers that multiply to give negative 3. Those same two numbers add to give negative 2. Someone whispered at me. One negative, one's positive, because we know we're going to multiply to get negative 3. What's the only way to get negative 3? What's the only way of multiplying something to get negative 3?
Oh, you have to do a hat, like decimal. 3 and 1. Oh, 3 and 1. That's good.
Okay, you will have it as negative 3 positive 1.
Yeah.
We've reviewed it. I thought we'd reviewed this. Have we not reviewed this?
We have.
Okay. I just haven't seen a moment. That means that our two values are
Plus 3 minus 1.
Oh, so that was that C. I don't know why I've done that. So D, what did D say? The basic shape, is it positively happy or negatively sad? So when I'm saying that, what are we looking at? The x squared term. So the value of funds of x squared, is that positive or negative?
Positive.
Positive. So we know it's happy. And E is talking about the turning points. So let's start sketching. And literally, a sketch is a sketch.
What about this one?
Oh, yeah, shush now, you've got one down there. So have I then. So we've got, what do we say? 3 and negative 1. Doesn't have to be to scale. Try and make it look a little bit like it should be. We know it goes through at negative 3 on the y-axis, so let's try and find negative 3 here. We know it's positively happy. Okay? So at this point here, we say, right, if I know it goes through negative 1 and 3, how many units is that across?
4.
4 units, yes? So how many units, or whereabouts is our axis of symmetry going to be?
1.
At the value of x is 1, yes? You'll have to do that.
Okay. Yes.
Because that is halfway between those two. That's a 1. That's a, okay. So we need to find out actually where does that stop, okay? Some people would think that this is our minimum point. Okay, it's really not. It's wherever the halfway point is going to be. So when x is 1, y is going to be 1 squared subtract 2 lots of 1 subtract 3. So what I'm doing is sticking that value into the equation. So that's 1 subtract 2 subtract 3, which is
1 minus 2 is minus 1. 1 minus 1?
I think that's touching dogs. I wasn't joking a little bit. And so that means that my minimum point is going to be down here.
Yeah.
And then we can sketch it. Beautiful. Job done. So as I said, it doesn't have to be the most perfect diagram. The important thing is that you label these points though. Okay, so don't just put dashes, actually put numbers there. Notice I haven't had to label everything. Okay, so you don't need to label all of these coordinates. You just identifying the key features. Alright. Oh, let's talk about this as well. Sometimes you are asked to identify the equation of a function from the graph. Okay, so you need to look at this and know what is going on with it. So, I know it's a parabola. We're going to identify the roots. What are my roots for this one? Not a trick question. 2 and negative 1, yeah? It says then use the roots to make factors. What that means is that we need to, because we know it goes through the value of positive 2 and negative 1, if I was writing it in factorized form, what would I have in my brackets?
X minus 2, x plus 1.
Oh, awesome. Now, you may think, well done. However, you do have to appreciate that there could actually be a value here in the front. Okay? So there could be a value in front of those two brackets. In order to determine if there is or is not, they will give you some additional information. They've given us the information that it crosses, the y-axis at -2. So we know it goes through the coordinate 0, -2. Yes? You know how to do that? So what we do then is to either expand the factors or substitute in that coordinate. So -2 is equal to a lots of 0 minus 2, 0 plus 1. So -2 equals -2a, so a is 1. Therefore, there is no value in front. My equation is just straightforward x minus 2, x plus 1. Are you with me?
Yeah, they're all I think like this is really something like taught us like if you expand them and then the y-intercept that you find after expanding is not the actual like y-intercept from the graph, then you can like
Yes.
work out the thing in front by just multiplying.
You totally can. So that's what this says. Expand factors to make sure you have the correct. So you can totally do that. Sometimes I think this just clarifies it a little bit. People don't always recognize what they need to multiply stuff by to get the y-intercept. Just like whichever method you're comfortable with and you've used before, go with that. Okay, I'm definitely not going to mark something wrong if you've done a slightly different way. Obviously for that one, if we did expand it, we would have x squared minus 2x plus 1x minus 2. It would give us the correct y-intercept, so we're good to go. Okay, either way, we've established that there is no number in front of that bracket. Those brackets. Okay, so this next one, we're going to do the same thing. So we've got crossing at +3 and +1. So what will our factors be? Yeah. We're going through the value of 9 on the y-axis. So you choose whichever method you want to do. What do you want? Should we go through my suggestion? Yeah. Shall I finish a sentence? I'm going to say potentially there could be an A there. We're going through the coordinate 0, 9. So we know that 9 would be equal to 0 minus 3. 0 minus 1. So 9 equals 3a. So a is 3. Yeah. I lost you. So -3, 0 taken away 3 is -3. 0 taken away 1 is -1. -1 multiplied by -3 is 3. Okay. So that's where the 3a is. I skipped 7, should have done, sorry. So that's -3. With the format of them, if they haven't specified, you can leave them in any format you wish, so you can leave it as in brackets if you want. They may have asked you to expand and identify certain values. That was more common in the Cambridge exam. So those of you who did that last year, you may have noticed it's more common that they ask you to identify the coefficients A, B, and C, and which would mean you need to expand it. But just check each question. This one here, my two intercepts are -4 and -2. So what are my roots? What do I know about this one straight away? Is this going to be my answer? Why not?
Negatively sad.
It's negatively sad, so there has to be some kind of negative value going on at some point. So we know it's not exact, so let's establish, so we know it could be a, x plus 4, x plus 2. We know it goes to the coordinate 0, negative 8. So we're now going to stick that in. So 0 plus 4 or 0 plus 2, so this is 4 and 2. So it gives us 8a, so then a is negative 1. So we've got y equals negative x plus 4, x plus 2. And again, you can expand that out and get rid of the negative. Well, include the negative into the adjustment. Ja? Ja?